look again at our reaction. HCl plus H2O. We already showed this energy diagram. We said the starting materials are going to be up here in energy, and somehow they're going to go through a process. This is going to be downhill, and we can actually feel that it's downhill. It's the reaction, the extent of the reaction, because mix HCl and water and it gets hot. We haven't talked at all about what this hump is in the middle of our energy diagram. Starting materials are easy to define. That's just HCl plus water. And I'm not showing them up at top, but we're going to make Cl minus and H3O plus. What happens in the middle? Well, it turns out in the middle, this peak is a theoretical point called the transition state. I'm going to write TS. Sometimes people will put it in brackets, and they give it the dreaded double dagger, but that stands for transition state. What is the transition state? The transition state is something in between your starting materials and your products. So for us, for this reaction, the transition state describes this bond forming and bond breaking process. So this is what our transition state might look like. We're going to go to having Cl minus plus H3O plus. So in our transition state, we're going to be breaking this HCl bond. So that's going to be a partial bond. And that chlorine is attached to that partial bond. Well, what's forming a new bond to hydrogen? It's our oxygen from water. So we're going to have a partial bond there. And our oxygen is also attached to two hydrogens. Those two hydrogens will still be attached to our oxygen, so we can leave those bonds regular. Now, in the process, in the in-between state, this oxygen has gone from being neutral to having a positive charge. So halfway in the reaction, it's going to have some degree of positive charge. This hydrogen starts neutral and finishes neutral, so there's no change there. But the chlorine goes from being neutral at the beginning to negative. So there's going to be a partial negative there. And this in-between state during the reaction is our transition state. So we can just label the energy point that's a transition state. But here is our actual picture of the transition state. Transition states always involve partial charges and partial bonds. And so that's how we represent this in-between state. This is not something that we can isolate and put in a bottle. It's a peak in energy, and therefore it's a hypothetical structure. But the reaction must go through this transition state in order to get down to the products. Now, sometimes, some reactions, so this is a one-step process. One step because it has one transition state. So the number of transition states tells you the number of steps. And I'm kind of going towards the fact that some reactions will have two peaks. This is two transition states. This transition state 1 and transition state 2. And so we've already defined that the starting point, or those are the starting materials, and we go over to the products. Well, then what the heck is this dip in the middle? That dip in the middle defines an intermediate. And intermediates are often put in brackets. And we'll label that I. Note that transition states, when we put transition states into brackets, we give it the double dagger. So this is a distinction. When you use brackets, if it's a regular bracket, it's an intermediate. A bracket with the double dagger means it's a transition state. So this intermediates are another thing that get formed when you talk a little bit more about what is an intermediate.